Hi everyone, I'm Sumalata, lecturer in physics, Government Degree College for Women, Madanapalli. In this lecture, I want to discuss about Carnot's engine. It is an heat engine which converts heat into work. It is a theoretical engine designed by the scientist Carnot. It is free from all the defects of practical engine. It cannot be realized in actual practice, but it can be used as standard engine. And it consists of four parts. The first one is working substance. It is nothing but an ideal gas which is enclosed in a cylinder which is fitted with a piston. Here the valves and piston are non-conducting but the base is conducting. And the second one is source. It is a hot body with high thermal capacity at a temperature T1 Kelvin. Third part is sink. It is a cold body which is maintained at lower temperature, that is T2 Kelvin. It is like our surroundings. The fourth part is insulating stand. It is a non-conducting stand. These are the pictures. Let we see the working of Carnot's engine. During the working of Carnot's engine, the working substance undergo a cyclic process which is made up of four parts. The first one, isothermal expansion. Here, the AB curve represents the isothermal expansion. BC curve represents adiabatic expansion. CD curve represents isothermal compression. DA curve represents adiabatic compression. Let me explain one by one. The first one, isothermal expansion. Initially, consider 1 gram mole of a gas contained in the cylinder. Here, A is the initial state of the gas where it has pressure P1, volume V1 and temperature T1. Now, the cylinder is placed on source and the piston is moved slowly upwards. Here, the base is conducting, so there is a heat flow from source to the gas so that the gas expands isothermally. Here the pressure will decrease and volume will increases. During this expansion, fall of temperature is compensated by supply of heat from the source. Finally, the gas is now at the final state B where the pressure P2, volume V2 and temperature T1. Here, the quantity of heat absorbed from the source Q1 is equal to the amount of work done W1 by the gas through this expansion from A to B. That is Q1 is equals to W1 is equals to integral V1 to V2 PdV. This is the total work done. That is equals to, we can replace P with RT1 by V by using Boyle's law. From after integration of this equation, we can get final equation like RT1 log base E V1 by V2. This work done is equals to the area under A B B dash A dash A. And the second one, adiabatic expansion. It represented by the curve BC. In this, the cylinder is detached from the source and is placed on insulating stand. Now the piston is allowed to move further adiabatically so that there is no heat flow between insulating stand and working substance, that is gas. This expansion continues till the temperature of gas is same as that of the temperature of sink, which is maintained at T2 Kelvin. Here, the gas does external work on piston by utilizing its internal energy. Finally, the gas comes to a state C, where the pressure P3, volume V3 and temperature T2. In this expansion, the work done by the gas W3 is equals to integral from V2 to V3 PdV. This is adiabatic process, that's why we can take the adiabatic relation. Then we can replace P with K by V power gamma. After integration, we will get this equation. This work done is equals to the area under BCC dash B dash B. Now, third part, that is isothermal compression. It can be represented by the curve seen in the figure. In this, the cylinder is separated from the insulating stand and placed on sink, which is at a temperature T2 Kelvin. Here, the gas is compressed isothermally because the developed heat compression is passes to the sink. The gas finally gets the state D, where the pressure P4, volume V4 and temperature T2. Now the quantity of heat rejected to the sink be Q2, that is equals to the work done on the gas. That can be represented by W3 is equals to integral V3 to V4 PdV. We again take Boyle's law and we can replace P with capital R T2 by V. After integration, we will get this equation and we can modify this equation into this one. So this work done in this isothermal compression is equals to the area under CC dash D dash DC curve. And last part is adiabatic compression. In this process, the cylinder is detached from the sink and placed on insulating stand. The gas is compressed such that it undergoes slow adiabatic compression till the temperature of gas rises to the initial temperature T1 and pressure P1. In this process, the work done on the gas that can be represented by this one W4, which is equals to the integral V4 to V1 PdV. We again take the adiabatic relation in this. We can get the final equation like this. This work done is equals to the area under D dash A dash AT. So these are the four operations. Now the net work done by the gas, that is W is equals to W1 plus W2 plus W3 plus W4, and we can substitute all the values from above four process. We can get the simplified equation RT1 log base E V2 by V1 minus RT2 log E V3 by V4. Now, the efficiency of the engine. It is the ratio between work done by the engine and the heat taken from the source. That is, it tells about how much of heat converted into work. That is equals to W by Q1. We can simplify the net work done by taking these two steps. That is, points B and C lie on the same adiabatic. So we can take this relation T1 V2 power gamma minus 1 is equals to T2 V3 power gamma minus 1. And from this equation we can get T1 by T2 is equals to V3 by V2 whole to the power of gamma minus 1. And again, points A and D also lie on the same adiabatic. So we can take this adiabatic relation. From this, we can get T1 by T2 is equals to V4 by V1 whole to the power of gamma minus 1. From these equations 7 and 8, we can get is V3 by V4 is equals to V2 by V1. Now, we can place this equation in fifth equation, so that we can get W is equals to capital R T1 minus T2 log base E V2 by V1. So we can substitute this net work done in efficiency equation, so that in eta is equals to W by Q1 is equals to, we can place this in place of W. So R T1 minus T2 into log base E V2 by V1 divided by RT1 log base E V2 by V1. We can cancel the similar terms, then we can finally get the equation eta is equals to T1 minus T2 by T1. I hope you are understanding about the Carnot engine and its efficiency equation. Thank you.